Today we're going to talk about rational numbers. Now, they may seem like it's a weird word, but it's actually not that hard to remember. So there's this little chart, and it helps you. You should know your natural numbers, and they are just 1, 2, 3. Whole numbers add a 0. Integers add negative and positive, and that's what we've been doing. And rational numbers are just fractions. So the main thing you need to remember about rational numbers is they're going to be fractions that end or repeat. And you'll see what I mean today. So that's what we're going to be working with today is rational numbers and rational numbers that are positive and negative. And remember, a rational number is just a fractions that end or repeat. So I'm going to show you how to do this today. So the last lesson we talked about integers. So integers are over here, and you can see that they're here. There's a -2, 0, 4. Integers are positive whole numbers, negative whole numbers, and 0. And in our chart, you could see that they were inside of the rational numbers. And then today we're going to do rational numbers. And they're positive whole numbers, negative whole numbers, 0, fractions, decimals. And it has to be a decimal that ends. It has to have an end to be a rational number. So it's actually decimals that end. It's not just decimals, they have to end. They can't be going on forever and ever and ever. An example is like if you had, I'm going to move it back over 1 second. An example is if you have pi. Pi is 3.14, but it actually goes on forever, so that's going to be an irrational number. So anything that goes on forever that never ends is going to be an irrational. But if it repeats, then it's a rational number, okay? So that's a little bit different. So now we're going to go through what a repeating decimal is. So a non-terminating decimal is actually a decimal. So a decimal that ends is a terminating decimal. And again, these are going to be your rational numbers. And decimals that never end are called non-terminating decimals. That means they go on forever. But non-terminating decimals that have a pattern are called repeating decimals. And these are kind of like their patterns. So one thing you need to know about repeating decimals, so if it's a non-terminating decimal, it's irrational. But if it's a non-terminating repeating decimal, then it's rational. So here you have 0.333 repeating. All you do when you write it out is you put the 0.33, and then you're going to put, actually because it's repeating with the 3, it's just going to be 0.3 and then a bar on top of it. The bar on top means that it is repeating. So 0.3 with a bar on top. Now you look at the next one and you can see that I'm going to get it a little bit bigger so you can kind of see it. So here's your 0.3. Now for the next one you can see that a repeat is, it goes 7, 2, 7, 2, 7, 2. So your repeating part is 7, 2. So it's going to be 1.72 with a bar on top of it, meaning that's going to repeat. And then the next one is 16.2545454 ... So you can see your repeating part is 5454. So you would write it 16.254 and then only put the line over the 54. So what I'm going to have you do is for the next two, which are down below, in a little bit, you're going to actually write them as a repeating decimal. But I'm going to go through a little bit more, and then I'm going to have you work on it. So the last thing I want you to look at before we get to it is comparing fractions and decimals. So I'm going to make it really big. So one way to compare fractions and decimals is to convert them to, so if you want to do it, if you want to compare fractions and decimals, the best way is convert it to decimals first. So you want to first convert them to decimals and compare using place values. So here's an example that I'm going to go through with you. So Elena and Rory each ordered a personal pizza. Elena ate 11/15 of her pizza, and Roy, I don't know why it changed, ate 0.78 of his pizza. Who ate a greater portion? So what I'm actually going to do is I'm going to get my calculator out. because it's just going to make it easier. So I'm just going to type in calculator and it's going to come up. I'll make it, oops, you're not going to be able to see what I'm doing because my calculator is way too big, but maybe I can get it small enough to get in there. So what it is I'm going to put in 11 divided by 15 because that's 11/15, and I get 0.7333 repeating. So I have 0.73 repeating. So 0.73 repeating and 0.78. Well, the 73 is smaller than 78, so who ate the greater portion? Well, that would mean that this one is larger, and it goes this way. So you can think of it as it points to the smaller, or the alligator eats the bigger. And I know that it's taught both ways, so you can have a face and it eats the bigger, or it points to the smaller. And so then that would be 0.78. So I'm going to have you do this page with the other page that we just went through, and then we're going to go through them, and we have one more thing after this.